It's on y'all. Mommy. Okay, look. So, guys, let's go over this and see how you did. Let's make sure they're all fair. Distinguish between anatomy versus physiology. I'm just going to quickly say, so we can move on. But anyway, anatomy is the study of form, structure, and location of those structures, where physiology is studying how they function, right? So as long as you said something like that. What exactly does DNA stand for? I had asked you, make sure you knew exactly. Deoxyribonucleic acid, it should have been spelled correctly. 4 major tissue types found in humans: epithelial, connective, nerve, and muscle. Name an example of an organelle. I gave you a few to remember, to recall. They were the nucleus, mitochondria, endoplasmic reticulum, the Golgi apparatus. So just have to name one. Which organ controls the pituitary? It's the hypothalamus. What's the function of prolactin? The function of prolactin is to produce milk. That really is the function of prolactin. What is the target of ADH? The target is the kidneys. It's released from where? Pituitary. And then I think I asked you, what's the function? So what's the function? I hope you put that it was to raise blood pressure, but I also hope you put that you knew how it does that. It does that by pulling water back from the filtrate that had happened in the kidney, so water stays in the blood plasma. So it reduces urine output, thereby increasing blood volume and raising blood pressure. So yeah, you only had to say raise blood pressure. If you answered that question by saying something like decreases urine output, I'm going to give you credit for that. But what I'm going to hope is that you knew the next step, because that's how you should be thinking about this stuff. Okay, so great. What does TSH stand for exactly? It stands for thyroid stimulating hormone. What hormone functions by targeting the ovaries and for egg maturation? Egg maturation and sperm production is because of follicle stimulating hormone. Follicle stimulating hormone. And what hormone targets for the uterine? Targets uterine contractions, milk injection, not production, but ejection, and emotional bonding is oxytocin. Which organ, other than the gonads, release sex hormones? Which one is that? That's the bonus question. Which one is that? The adrenal glands. So that was the bonus. So the maximum points are 100. Some of you might have gotten all of them, but your maximum score is 100, but I appreciate you getting all of them. And so that's great. Any questions for me about this? Were they all fair? Were they? I'm asking that seriously. So they all seem kind of fair? All right, from what we talked about the other day. All right, great. Great. Do I have any questions or issues or concerns or hopefully not. But do I? Any issues? Anything that y'all are just, okay, related to this class that I could help with? Yes.
The due dates for the
lab?
lab.
Yeah, that's what I'm about to show you. So thank you so much. I am about to show you that. And this is important that you know. I wish I knew how to quickly do this. All right, so guys, this visible body thing that you guys just purchased, and it does hurt my feelings about how much things cost. You own that now, so you can download it to a mobile device or an iPad or whatever, and you can do anything that they've got on there. You'll have 4 different little tabs that one of them's mostly physiology, another's anatomy. It's called the Atlas, and so you can do it all. You've got it, and you'll keep it past this course. But you'll also, once you register for my course, our course, you'll see assignments under that course. So you click on the assignments, and you'll see that I've published a couple of things there. I think. Did you see them? Okay, we can make sure. But yeah, I'm pretty sure those. But I want you to know that it's a lot in those assignments that you might not necessarily be responsible for. So I have published the Endocrine Atlas, a couple things for you to look at. But what have I told you you will have to label on that lab quiz that I give you? I've told you that you'll have those 10 major endocrine organs. So there's a lot more on that visible body assignment tab than you would have to do for me. I'm telling you what's on the lab quiz. The lab quiz for the endocrine system will be that you have to know where those 10 major endocrine glands are and be able to label them. I would love for you to use the visible body because it's awesome. So use that as a resource, but we'll be doing some things in here as well. Now, the first lab quiz that you have for me though, I have put an assignment on there that is talking about directional terms and some basic medical terminology. Those two things that you see in the visible body assignments for that will be your first lab quiz, and anything that's in there is fair. I'm telling you right now. So you'll see some terminology that should be very familiar to you, and you'll see directional terms. Anything that's on there is fair for me to ask you a question about on the first lab quiz. The second lab quiz is going to be labeling those 10 major organs. Fair enough? Now, there are a lot more organs and things you could label on the visible body for the endocrine system. But what are you going to be responsible for me? The 10. Fair? Do you have any other questions?
So do we have to turn in that packet?
You have the packet.
Do we have to turn anything in off of that?
No.
Okay.
Not now. If I get to something in the future and I see something and think, you know, I want them to prove they did this, or sounds like an office job. No, it isn't. It's just I know you're busy, but I haven't seen anything like that so far. I'm just telling you, this is just an additional resource for you, right? Right? Okay. So, okay, and I thought I could get to this. So I can get to this. So guys, like this visible body, how many of you not seen it? How many of you not seen it? So you get to download it. Once you register at the site, they'll let you download it to one device. So if you have an iPad that you want it at, or a phone, they say most youngsters are using their phones for this. But once it's there, you can do all kinds of things with the structure, right? So just using your finger or whatever, you can turn it and you can look at it from a superior view, a lateral view, inferior view. You get what I'm saying? So that's kind of cool. But there's also something else. It's called augmented reality. And what augmented reality is that you have to find a surface. Well, wait a minute, let me get, so this is like in the room so y'all can see it. So once you have a surface, it's a little square box that's posting up. Once you have that square box, I want you all to see, without me standing here. Do y'all see it looks like this thing is in our room with us? The structure is in here with us. Can y'all see that? Can everybody see that? So you can actually do that for any of these. Were y'all able to see? It is kind of cool, right? So there's like a lot of stuff in here, but it's mostly, I think the coolest part about this visible body is the anatomy. Because you can click on, let me find him again, see he's still here. You see him, guys? Y'all see him still here in the room with us? But you can click on a structure and then it'll highlight it and the name comes up, and then there's this little, you'll see it, it's like a little speaker thing. You can click on that and it pronounces the structure. So there's so many functions within this, and I sound like I'm trying to sell it to you, but you guys you've had to buy it, so whatever, but you'll have it. It's yours after that, and it doesn't go away after this semester. The class, where you see my courses, my class will disappear for you, but you will have this. This will be your software after that. And you just play with it, okay? Now, if you ever have questions, and I'm sure you will, about the assignments, I'm going to verbally tell you within the assignment what you're responsible for, like I just did with the endocrine system. You're responsible for the 10 organs that I've shown you. There's a whole bunch of other stuff. Have fun with it, okay? But you're responsible for the 10. then I've told you to know where they are. Same thing with the first lab that you have. You're responsible for everything. I've published on that. So make sure you go through. And there's some things, it's medical terminology, but it's also it's directional terms and stuff. Okay, so we're back to studying, looking at the endocrine system. Is that right? And so far, we've talked about the hypothalamus. Is that true? We talked about the hypothalamus. I feel like people have questions. Is that pretty good? All right, we talked about the hypothalamus. We've talked about the pituitary. And we looked at 8 hormones that are going to be released from the pituitary, 6 that are actually produced in the pituitary, 2 that are just going to be released from it. But we understand for every hormone we mention, you could maybe start a chart with this. You have to know where it's from, if there's a specific target, what that target is, and what its function is for every hormone. All right, so you're starting your list. And you've already got 8, don't you? And we know that hormones are just molecules that signal a response in their target cells. Sometimes those target cells are really far-reaching. This is a little bit of a different picture than we had yesterday because I couldn't find that PowerPoint. So that's okay. Because, you know, we need to look at different pictures. That's why we want to go on visible body and look at them at inferior aspects, lateral, superior. We want to look at them every which way, right? But anyway, these are the major endocrine organs here. And we're going to move on along and leave the pituitary. These are kind of cool because you've got these scans here, which are cool. Leave this pituitary gland. You can see this is also, these are some great pictures that were just also included in your textbook. And gosh, I didn't know there were so many things. Okay, whatever. Let's go. Sorry. Okay, just be happy I'm not reading it to you, all right? Let's see. I've got to keep going. Keep going. Okay. Really? All right. So we had said growth hormone. Where did we say growth hormone targets? Where did we talk about growth hormone targets? What did we say? We said it targets the liver. And we know that the liver actually produces another molecule that helps the growth hormone carry out its functions that are widespread. But what I really mostly want you to know is that it is going to increase mitosis. It is actually going to increase protein synthesis. And we're going to tell you your cells are essentially, your cells can produce carbohydrates and can produce, you know, fats and lipids and whatnot, and even build nucleic acids. But what are your cells essentially? What kind of factories? Protein factories. And it's the proteins that are the most diverse category of organic molecules that living cells make. And it's the proteins that you really have to know and realize are the ones that are helping cells be able to do the most amazing functions that they do, right? We talked about proteins being embedded in cell membranes that act as receptors and act as like recognition proteins, act as tunnels and that sort of thing. We said that they, inside the cells, are forming the framework of the cytoskeleton. Proteins are we make proteins, our cells make proteins that we call antibodies, and antibodies protect you, don't they? You remember how amazing your proteins are? There was one whole category of proteins, though, that we call catalysts. What do catalysts do? They speed up reactions, don't they? These catalysts, these enzymes that speed up reactions, that make things happen at a pace in the cell that is almost beyond comprehension. How fast cells can do the work that they do. But for all that work, do you have energy? You have to have energy for all that work, right? So we know that you have to have energy, and we talked about how the cell best gets its energy. How does it? Aerobic respiration. Were you all ready for that equation today? I forgot to put it on there. But does that mean it could be on your first test, though? Y'all studied a lot of things, and they might be on that first test. They probably will be in a multiple choice question. But you're ready for them because you were ready for it today. So now it's just review up to this point. Okay, so we're moving kind of along. If we think, well, the way this is a little bit different, so I'll just go by the PowerPoints. So when we look at the pineal gland, this pineal gland is posterior to the pituitary. If you'll just bear with me for a second, thinking about like where the hypothalamus is and a little stalk of tissue that connects that to the pituitary, right toward the front, if you will. But behind that, slightly behind that, is this pineal gland. It's a tiny little gland, and actually here's a picture. I'm not sure why I'm standing up here doing this, but here's a picture of this, and you're going to see pictures in your visible body. And what I want you to know about this gland is that it secretes serotonin by day that ends up being converted to melatonin by night. And I want you to know what the functions of those are. The functions are widespread, so there's not going to be a particular target. The functions are kind of widespread. But what I want you to know is that this gland is also sometimes called the third eye. The third eye. And the reason it is if you think about looking at somebody's eyes, looking them in the eyes, right in the middle, behind their eyes, sort of the middle, right behind that optic chiasm is this gland. And this gland is completely dependent on sunlight for its functions. So this is something we need to realize, that the amount of exposure to daylight, like today walking into the college this morning, I thought, I wish I could take this whole class and we could go outside and have this class today. It wasn't nice to see the sun. So, because it's been kind of dreary, it's been a lot of rain lately. But anyway, it just makes you feel better. If you've ever wondered why that is, let me just tell you, we're animals. And we are not nocturnal creatures. We are not. In the dark, can we see with our eyes? Can we see? We cannot. We have rods as receptors in our eyes that can do sort of gray, black, whatever, and we can see images somewhat. But we would step off that cliff and we would be caught by that predator if we were out at night without some sort of artificial light, because we can't see, right? We can't see at night. And here's the thing. We're not supposed to be up at night. When the sun goes down, we're supposed to be someplace we're resting. Because when the sun comes up, this pineal gland is going to be stimulated, and we're going to be producing serotonin that is going to be released, that makes us want to get up, realize we're hungry, and start to function, right? Make sure that we have what we need for the day to survive. Serotonin is going to be produced, and then by the evening, serotonin is being converted to melatonin, which is making you feel like, okay, I need to rest. Is rest a vital part of health? Mm-hmm. Is sleep a vital part of health? It absolutely is. We talked about that in AMP1, how vital it is that you get that, that sleep that you need, that has those significant number of REM events, right, that end up increasing the longer that you are in that sleep pattern. So getting that is really important for every other organ system. And the melatonin helps you have that feeling, right? So people who don't get enough exposure to actual natural sunlight, and it doesn't mean you're laying in the sun, that's not healthy either, right? But that you're not out enough and you're not getting enough exposure, can have something, you're very sensitive to it, it can have something called seasonal affective disorder. It's referred to as SAD, seasonal affective disorder. Because we know that what happens in the northern hemisphere as far as the length of the daylight in the winter months, what happens to the length of daylight? It shortens. And just enough of that is enough to cause some people to feel very depressed. I don't like that term, depressed. The reason I don't, and I know this is repeat from AMP1 because we talked about this in the nervous system, but the reason I don't like that is because there's a stigma associated with that due to a lack of information and education. There's a stigma associated with depression, the word depression, and it should not be. It's because of a lack of education. But what can happen is people can have a clinical chemical depression where they are not producing enough serotonin to feel like functioning. And what would be one of the best things to tell somebody? Get outside. Instead, But actually, instead of writing scripts and trying to change neurochemistry, right, maybe along with that is to say, turn electronic devices off as the sun is going down. Try to change your pattern of sleep that it's during those dark hours. Get up early, watch the sun come up. Even if you don't feel like it, take a walk when the sun's coming up. Try to get outside more during the day. Because honestly, this is what this gland does. This is what it does, and this is how what it needs to function. So what do we have in this country, and not just this country, but all developed countries right now, is an epidemic of depression. An epidemic. So some things are just physiological, and we understand how they're working. In seasonal affective disorder, what happens is people are actually, the melatonin is hanging around too long. So it's the melatonin that is hanging around too long, and they're not getting that daybreak drop in the melatonin with the serotonin kicking in. So seasonal affective disorder. It has also been linked to the PMS. So you guys know what PMS stands for? Is that on here? It's been linked to that as well. So just so that you know that. Symptoms. Some people who are really sensitive to the symptoms. The thymus gland, and you can see where the thymus gland is. If you look at this child, you see that the thymus gland is going to be like really, this is the thymus gland. I need glasses. It's huge. And then as an adult, it has really involuted. It's shrunken, hasn't it? So you see this kind of adult male here where it looks like it's much smaller. The thymus gland is a major organ of your immune system, of the lymphatic system, the immune system. Because the thymus gland is going to be secreting a group of hormones that I want you to know collectively are called thymosins. Thymosins, collectively. It's a group of them that are called thymosins. And what I would like you to know about this is that these thymosins are absolutely required for a very special type of white blood cell that you have to mature. Your white blood cells, actually all of them, and your red cells and your platelets, come from stem cells in the bone marrow. Okay? But there's a special type of one of those white cells. Yes, the stem cells are found in the bone marrow, but there's a special type of them that they can't mature unless the thymus gland is secreting the hormone, these hormones. And just know thymosin. It's kind of, we call it, it's kind of like a little group. That's fine, thymosin. This hormone actually helps with the maturation of a special type of white blood cell called T lymphocytes. Lymphocytes. There are different types of lymphocytes. This is just one type of lymphocyte, and they're referred to as T lymphocytes because they're dependent on which organ? The thymus. So if I were to ask you what does the thymus gland secrete, you'd say thymosins, and then you'd say thymosins target T lymphocytes, and then you'd say that that function is to protect you because they are white blood cells and they do protect. We're going to learn a lot more about them in hematology. When we get to the hematology chapter, the study of blood, we're going to learn a lot more about them. But right now, you know that, right? As a child, why does a child's thymus, why is it so big? Well, an infant hasn't been exposed to anything really until, hopefully, until the amniotic sac breaks. And then that neonate starts getting exposed to normal vaginal flora, starts getting exposed to skin flora, because people, have you seen people walk up to your infant and put their finger in his mouth to see if it'll suck? And you think, what the heck are you doing? Have you seen that? Or kiss them right on the mouth? Okay, don't want to do that. But anyway, babies are being exposed to a lot of flora, and that's good. It's a good thing. That's a normal thing. But it is the thymus that has to release these thymosins to train all those T lymphocytes so that those T lymphocytes figure out what is normal and what is potentially pathogenic. Without this gland, the babies can't do that. Babies that are born without a functioning thymus are what y'all call bubble babies. Have y'all ever heard of the bubble babies? And usually they call them bubble boys because it's usually males. but they have to be put in a sterile environment. Without that, they would die. So the thymus is quite important, obviously. So as an infant goes into toddlerhood, goes into, you know, early childhood, they're being exposed to everything new. And by the way, when something's new, your immune system has to learn it. It has to be figure it out. By the time we're adults, we've been exposed to a lot of stuff in our ecosystem. You know, unless we're traveling someplace it's crazy. But anyway, that we don't know stuff. They wouldn't be crazy places. It would just be, never mind, just scratch that. But anyway, so the thymus is involuted by this time as young adults because it kind of knows everything in an ecosystem now. And by the time you're senior citizens, this thymus is involuted so much it's being replaced by adipose. And this is why, when you think about immune issues, who is most at risk? Infants who are just learning everything and their thymus is being so challenged, and who? The elderly. I said senior, not elderly. Okay, no. So the elderly. So this is why they're the most at risk for infectious diseases and even metabolic disorders that can lead to infectious diseases, is because of this thymus. It's a wonderful organ and it has doing amazing things. But anyway, so you can see where it's located. Lots of pictures of it. You can actually see on cadaver. Do you see what I mean about cadavers? Well, this is actually, I think, under the reveal thing, but it still looks like a little bit, not exactly. That's the baby. Okay, so whatever. So y'all can look at a lot of different pictures of this. The thyroid gland. The thyroid gland is going to be this butterfly-shaped gland that's in sort of the base of your throat. If you don't push too, you shouldn't push too hard on the base of your throat. But when you swallow, you can kind of feel this gland. But anyway, this thymus gland, this thyroid, what was I saying, thymus? This thyroid gland that's right here, it secretes, I'm going to want you all to know, 3 hormones. I want you to know from this. Okay, so 3 hormones, and here they are. We already know something about the thyroid gland. We know that this thyroid gland is actually going to be targeted by which hormone from the pituitary? The thyroid stimulating hormone. We know the thyroid's going to be targeting it to release something. And what I want you to know those somethings are because of TSH, are going to be, and it's somewhere in these notes, but whatever, it's going to be T3 and T4, they're called. Now, I do want you to, and it's right here in this PowerPoint somewhere, but I want you to know that T3 stands for triiodothyronine. Now, you don't have to write that in your notes, but just take a minute to look it up sometime. Okay, great, thank you. Like I said, I keep saying triiodothyronine, and T4 is actually thyroxine. So, but these, as long as you know T3, T4, and you've heard of those names, that'll be fine. T3 and T4. What these are going to do they're going to be released into the bloodstream, and they're going to target all your cells. And they're going to tell your cells to ratchet up metabolism. So the TSH does increase metabolism, but it does it because it's signaling the thyroid to release T3 and T4. Are there any questions about that? And then T3 and T4 are going to tell every cell in your body to ratchet up metabolism. Yes, Sarah. Yes, their functions are to increase metabolism. That's exactly right. So T3 and T4. Are you good with that? Now, am I going to ask you if it's follicular versus parafollicular cells that do it? No. No. I don't care that you know that. I just want you to know the hormones, what they're doing. Now, I said T3 and T4 because the 3 and the 4, you do need to know this, they're named this because that's how many molecules, atoms of iodine are needed to make them. So we have iodine. Where do we get iodine in our diet from? Where do we get iodine from? Does anybody know? Salt. Our salt has added iodine to it. Because not all naturally occurring salt has it, but we have it added to our iodine, and that's actually a good thing. So here's the thing. We don't need all the salt we take in. But anyway, if you were in an area, though, that still had, you ate everything from your farm, and you raised your animals on your farm, and then, slaughtered them and ate them, and you were still like that, if your land was low in iodine, then you wouldn't be getting it, would you? So that wasn't uncommon many years ago. And so what we saw were people had iodine deficiencies, and it was very, very common that people had iodine deficiencies. That is not common anymore, because almost every packaged food that you eat, and a lot of people eat packaged foods, has crazy amounts of salt that's been added, that's iodine's been added to the salt, right? So we don't see too many iodine deficiencies anymore, but every now and then we do. And what happens is the thyroid gland is getting a signal from the pituitary, from TSH, to make T3 and T4. The TSH is going up and up and up because it's trying, the pituitary is trying to tell the thyroid, do your work, do your work. So the thyroid is enlarging, and it can't make T3 and T4 because it doesn't have what? So, but it's trying, so it's ended up enlarging, enlarging, enlarging. And I want you to know an enlarged thyroid gland is called a goiter. It's called a goiter. Now, a goiter is not a diagnosis. Let me say this, a goiter. I hate these names. Okay, so, but y'all already know what I'm saying. A goiter is a diagnosis, is not a diagnosis for iodine deficiency, because there's lots of other things that can cause a goiter. But is it one diagnosis that could be potential for an enlarged thyroid? Is it one diagnosis? It might be, right? So that is actually referred to as an endemic goiter. Endemic, E-N-D-E-M-I-C. Endemic goiter means that there's an iodine deficiency. The thyroid is trying to work because TSH is getting sky high, pushing the thyroid to work, but the thyroid can't make T3 and T4 because it doesn't have what? Iodine. Great. Great. Now, I want to talk to you about this. Well, I don't want to talk about parathyroid. I want to talk to you about this right here because I hope this is an anterior view of the throat, right? The trachea is underneath this. So you see this. Okay. There are other diagnoses for goiters. A goiter is an enlarged thyroid. Sometimes people have an autoimmune disease. It's an autoimmune disease where they will make antibodies that destroy these cells, these special cells that actually make T3 and T4. So an autoimmune disease. Let me tell you what that disease is going to be called. It's called Hashimoto's. Who's heard of Hashimoto's? Did I tell you about Hashimoto's? Okay. Hashimoto's, and it's called thyroiditis. Thyroiditis. But anyway, Hashimoto's. It's a very common autoimmune disease of the thyroid gland. 1 in 8 women by the age of 30, 1 in 8 have this. An autoimmune disease. Tell me again what an autoimmune disease is.
The body attacks its own self.
It means your immune system, which we just said was amazing, but needs to be kept in check, doesn't it? Has all of a sudden started to attack your own cells, which it really should never do. But that is an autoimmune disease, and this is one. So what's going to happen is that these antibodies that your immune system makes attacks these tissues that make T3 and T4, and you can't make it. And wait a minute, but in the body sending a signal that you need your metabolism to go back up? Your body's sending the signal to the hypothalamus, which is sending it to the pituitary to make TSH. So what's happening to your TSH levels? They're going up. They're going up, and they're trying to tell the thyroid to work. So the thyroid can be enlarging because of that. and that's a goiter because of a hypothyroidism. This causes a do you think you need to know whether it's a low secretion or a high secretion? Hypothyroidism. And again, this is one diagnosis of a potential goiter. All right, let me give you another example of something. There's another autoimmune disease. It's called Graves' disease. Does anybody know anybody with Graves' disease? Nobody in here knows anybody with Graves' disease? Okay. This causes what we call a toxic goiter. A toxic goiter. This means somebody comes in with an enlarged thyroid and you find out that they're not hypothyroid. In Graves' disease, they are hyperthyroid. What does that mean? They're making too much T3 and T4 because they have an autoimmune disease that produces antibodies that mimic TSH. And if a molecule comes to the thyroid gland that's mimicking TSH, what's the thyroid gland going to do? Make T3 and T4. So that thyroid gland is making T3 and T4 because of this con artist, these antibodies that are mimicking TSH. And it just keeps doing it. And the thyroid gland starts to enlarge because it's working so hard. So this is a hyperthyroid. This is a hypothyroid. Tell me how a person's feeling with hypothyroid. Tell me the symptoms they're feeling, exhibiting. What are they coming to you? What are they looking like if they're hypothyroid? They're tired. They're cold when nobody else is cold in the room, right? Because they can't thermoregulate to increase their metabolism just to stay warm. So they're cold, they're tired. They may have their skin, tell you that their skin is dry or rashy or itchy. They may tell you that they have changes in their hair. They may say that they have trouble even just thinking or finishing sentences or whatever. They're just tired because their metabolism is slowing down. How about gaining weight? Mm-hmm. They may be gaining weight. How about hyperthyroidism? What are they doing?
Really skinny.
They may have symptoms of almost what seems like anxiety, but they are losing weight, and they still may have skin and hair and whatever issues, but because again, metabolism plays a role in that, and you can have too much of a good thing. And so, yeah, they're kind of the opposite. They're hot when nobody else is hot, and they may be losing weight, but their diet didn't change, and so they have been some kind of these opposite issues. There's also a symptom that goes along with this that you all want to know. It's called exophthalmos. Does anybody know what that is? Janet knows. What is it, Janet? Yeah, it's blood out. Yeah. So and Janet said the eyes are kind of bulging. People call this, I'm not calling this. It's called like their eyes pop-eyed or whatever. The whites will show around the irises because the eyes will literally, pressure behind the eyes are affected, and so they really will look like they're bulging. This can be a sign of hyperthyroidism, Graves' disease.
What did you say they told you?
Exophthalmos. Exophthalmos. It's in the notes. It's in these notes somewhere. So we want our thyroid working, don't we? We want the pituitary sending TSH when it needs to and not when it doesn't. We want everything to be balanced. We want T3 and T4 to be balanced. And as soon as metabolism starts to come back up, then we want TSH levels to go down so that we can stay where we need to stay in homeostasis for metabolism. Because I need for you all to realize metabolism really is controlling the function of all the other organ systems. The skin, how the skin is undergoing mitosis, the keratin that's being produced in the skin, hair, and nails. Your digestive system is going to be greatly influenced by this. So we need all of this working, right? All right, now, behind, and I don't care about the histology, nobody's going to ask you that. if I looked at a posterior view of somebody and I could see right through here where my hand is, I would see the thyroid gland is wrapped around the trachea. It's wrapped around the trachea. So these are this is the thyroid. But on the posterior aspect of the thyroid are these 4 tiny little glands. These 4 tiny little glands, they're called parathyroid glands because they're neighboring. Para means neighboring, near, next to, beside, right? Parathyroid glands. These glands are right there sitting up cozy there. These secrete something called parathyroid hormone. Are y'all adding to your hormone list now? Oh, wait. Oh, my God. Okay, write that down, and then we're going back. Are y'all worried about me? Don't be worried about me, Janet. Maybe my thyroid levels are wrong. Look, so no. Can I go back to a second for thyroid? Because I had one more to tell you about thyroid. So in your notes, try to do a little arrow. You're still at the thyroid you talked about. What were the 2 that I gave you? T3 and T4. I'm sorry, guys, we need to add one more. Y'all already know this one because it's AMP1. You need to add one more from the thyroid, and it's calcitonin. Calcitonin. Y'all remember that from AMP1? Okay, calcitonin. It's a hormone from the thyroid gland. Calcitonin is a hormone that will target stem cells to become osteoblast. Osteoblast, one word. Blast with a B. What do y'all know osteo means? Bone. What do you know blast is?
Immature cell.
An immature cell. So an osteoblast will become an osteocyte. And what is an osteocyte? Mature bone cell. So are you telling me that calcitonin is going to cause you to make bone? Produce bone? Is that what you're saying? It is. What is bone mostly made out of? Calcium. And so where are we going to get the calcium to make the new bone cells? Where are we going to get it from? The blood. So calcitonin causes blood calcium levels to do what? Drop. Blood calcium levels to drop. Do y'all remember that? Is this ringing any bells? Why are we so happy that there is something that we know can help to monitor blood calcium levels? Why do we need to keep blood calcium levels in homeostasis? Now, you can tell me it's so that you're healthy, but that's not enough. Okay, why? Because, of course, we need to be in homeostasis for health, for balance, for well-being. Why? Does blood calcium levels need to not be too high? Why is blood calcium levels being in homeostasis one of the most vital electrolytes you need to be maintained? And your body cannot withstand much differences, too high or too low. Your body cannot withstand it. This is why it's such an amazing thing that our bones, remember, are mineral reservoirs. We can store calcium there when we need to get rid of it, when it's too high in the bloodstream, and we can pull it out of bones when calcium gets too low. Because we can withstand quite a bit of things being out of homeostasis for a bit of time, but not calcium. So we said our bones, everybody thinks they protect and they support and they help with movement. Yes, they do. But what's making them protect you today and the next few hours not dying is that it's protecting you from blood calcium level imbalances. If blood calcium level is too high, we can store it in the bones by making bone. And when it gets too low, we can break bone down and it'll come back up, blood calcium levels. Why is blood calcium imbalances so dangerous? What does calcium do for you?
You can go to places it's not supposed to be.
No, that's a bone disorder. I'm talking about for other things other than related to bone. So blood calcium levels need to be in homeostasis because it has to be balanced for nerve transmission Proper nerve transmission. What organ system is keeping everything in homeostasis? Nervous system. So if blood calcium levels get off, are you telling me it's throwing your nervous system off? Yes. Another thing, muscle contraction. Don't y'all remember the calcium part of your muscle innervation story? Do you remember that, the sliding filament? Yes, y'all remember that. So muscle contractions. You're telling me that if calcium levels are off, you might start constricting or not being able to, depending on what it is, right? So muscle contract, nerve transmission, muscle contraction, and blood clotting. For proper blood clotting. So if you are a healthy, young, prime adult in the prime of your life, and your calcium levels are getting off, and it's not that you're not going to say because you need it for strong bones and teeth. That's what an elementary school student would say. You're going to say that prime person in the prime of their life can be dead in your ER tonight because their calcium levels were off, because they are now, their muscles are contracting, they're having heart arrhythmias, and their nervous system is shot. And nothing, we can't keep them back, we can't get them back in balance, right? So calcium homeostasis, if it's out, can take you out of the world today. So those things are the reasons you want to know that calcium is important to be maintained. And what is a hormone we know that plays a major role in it? What's a hormone? What did I just tell you? Calcitonin. And it does what to blood calcium levels? Lowers it. Okay, now I need you to look at this one. This is the one that does the opposite. It's going to bring it back up. Parathyroid hormone is going to bring it back up when it starts to get low. Parathyroid hormone is going to bring blood calcium levels, going to raise blood calcium levels. That's its function. That's its function, is to raise blood calcium levels. It does it by several different ways. It does it by causing the kidneys, targeting the kidneys to release calcitriol. And then calcitriol, just so you guys kind of remember this from AP1, calcitriol is going to help us with vitamin D absorption and keeping calcium in the system. It's going to target the intestines so that when you eat something that's rich in calcium, it doesn't just go right through that tube. It actually gets absorbed. So are you telling me that we have to have the right balance of hormones being released to dictate which foods get absorbed? Just because you swallow something doesn't mean it's going to be absorbed. Not at all. Hormones that are present in the intestines play a huge role as to whether something will be allowed in or not. So the intestines are going to be targeted so calcium, if you eat something with calcium, can be absorbed. And then it's also going to target the kidneys, not only for calcitriol secretion, but also to targeting the kidneys so that the kidneys won't filter the calcium out. What did I tell y'all urine really just is? What is it? Filtered blood plasma. So it's going to cause the kidneys to keep calcium back in the bloodstream. So there's a ton of ways. It does target the bone and initiates osteoclast with a C. Osteoclast. What kind of cells are they? Osteoclast. What's their function? Remember?
Break down bone.
Would you say, Brittany?
They break down the bone.
They break down bone. And when bone is dissolved, what's it mostly made of?
Calcium.
And where's that calcium going to be released into? And what's going to happen to blood calcium levels? They're going to increase. These are all the ways blood parathyroid hormone does that. If someone has a thyroidectomy, what would that mean, a thyroidectomy? If they have a thyroidectomy and by accident the parathyroid glands get removed too, they'll be dead in a very short order. Blood calcium levels won't be able to be maintained. They will go into hypocalcemia. What does hypocalcemia mean? Low calcium in the bloodstream. Hypocalcemia. Right? Emia as a suffix always means what? In the bloodstream. Hypo always means low. So hypocalcemia. And if they go into hypocalcemia, that is a major cause of what we call tetany. Write that down, tetany. Y'all had this in AP1, but those of you who didn't have any might not have had tetany, T-E-T-A-N-Y. What does tetany mean? What do y'all remember tetany means?
Constriction.
Good, Janet. Say it loud.
Sustained muscle contraction.
Sustained muscle contractions. Should muscles stay contracted? Or was half of the story understanding that muscles need to go through a relaxation? They should not stay contracted. So sustained muscle contractions like tetany can cause the larynx, which is just the muscles of the vocal cords, to shut down and close. What can't move? If the larynx spasms, what can't move? Air can't move through the trachea. And you have 4 minutes to put a trach in. 4 minutes if that happens to somebody. Muscle contractions, sustained muscle contractions can also affect the diaphragm. If the diaphragm can't move and these intercostal muscles can't move, what can't change shape? The lungs can't change shape. What's the only reason air is moving in and out of your lungs? You're not sitting there going, you're not doing that. Air's moving in and out of your lungs because they're changing shape and size. If those muscles have done that, air's not moving. If the larynx is closed off, air has nowhere to move to the trachea. It's deadly. Hypocalcemia can be deadly because it causes tetany. Okay. Are we good? Are we good, everybody? All right, so parathyroid hormone, we're good because calcitonin is going to help to decrease it when it needs to be by making bone, and parathyroid hormone is going to raise it when you need it because it's going to tear down bone. And this is what we understood about bone being a dynamic tissue, didn't we? Because we said that bone is constantly being broken down and it's constantly being built back, isn't it? Throughout our lives, it's that living dynamic tissue. All right, so the adrenal glands. Ready for the adrenal glands? The adrenal glands, where are they sitting? Where are they? They're sitting just superior to the kidneys, just on top of kidneys, like little hats, you know, on top of the kidneys. You can see from this cadaver, the kidneys here, and these little glands that are right above it. So the adrenal glands, yes, histologically, if we did a section of these adrenal glands and looked at them histologically, we would see a difference. They would look different zones of cells, and if their anatomy looks different, it's likely that their what is different? Functions. So these different zones have different hormones that are related to them. But am I going to have you know that? No. But what I am going to want you to know is actually the hormones that are released from the adrenal glands. And so let's get to them. Let's talk about first the middle, the medulla, versus the cortex, which is the outer. Okay, so let's talk about the middle. The middle of the adrenal glands releases what we call epinorepinephrine. And y'all have already heard of this. Y'all have already heard of epi and norepinephrine, haven't you? You heard about it as acting as neurotransmitters, right? So you've heard this, and you've seen that these, or maybe you remember, that these are the vital molecules, if you will, that act on the sympathetic nervous system. Do you remember the sympathetic nervous system? And what did the sympathetic nervous system, what did we call that system? It's not probably right behind. What did we call that system? We called it our fight or flight response, didn't we? We said that this gives us that fight or flight response because we are animals. We live in that kind of dangerous ecosystems, and we need to be able to respond to threats and whatever. So we have this ability to have this fight or flight mechanism that will get us through stressful times, right? These are the hormones that this is what does this. So what happens to vital signs when these get released from the adrenal medulla into the body, into the bloodstream? What happens to people's vital signs? What happens to respirations? They increase. So they go from 12, if they're, let's say they're 16 per minute normally at rest, they're going to go up, aren't they? They're going to go up. What happens to blood pressure? It increases. It increases because actually the smooth muscle on our blood vessels clamp down. And as those smooth muscles clamp down on our blood vessels, the volume didn't change of the blood, so the pressure is increased. And when that pressure is increased, will blood be moving faster? Will it be being pushed faster? Not only will that cause blood to get to these large muscle groups faster, but something else will help it get there faster, and that's that the heart itself will beat more frequently. So the heart rate goes up, but not just that, the heart contraction strength goes up. So it's not just that your heart starts beating faster, your heart starts beating harder. And that's also going to get blood to these major muscle groups so that you can either fight or you can do what? Run. Hopefully you wouldn't run like that. But you can fight or you will run. Is that right? And this is a good thing. Now, this actually does cause stimulation to the heart, to the smooth muscle around the blood vessels. But the airways, it actually relaxes. Why would it do that? Why, depending on its target, it's doing two completely different things? Because if the airways relax, what can get in better? Air. And what do we need for energy in our cells? We need oxygen, part of aerobic respiration. So those airways are going to open up. This is why, and we had a student this morning sitting in there. They had left her by herself. I was on the home that said, the instructor said, the student who has a shellfish allergy, and we were doing crustaceans, and she can't breathe, and she has eyes, and she has eyes in the upper airway. It's her upper airways? So where is she? So anyway, no, it started going, and she's got ice on it. I said, do you have an EpiPen? She said, yeah. And I was thinking, okay, well, this is freezing. So anyway, why do you do an EpiPen? And then I said, don't leave her alone. So, okay, an EpiPen is because it's going to open up the airways. Can allergies and reactants close your airways down?
Yeah.
Yes, they can. So this is why you give somebody an EpiPen. But you don't do it willy-nilly. Because when you give them an EpiPen, what's going to happen to the heart rate? What's going to happen to the heart contraction strength? So when you give EpiPen, it's a serious drug. You need to be knowing what you're doing because you got to watch that there may be a cardiovascular incident because of it. But what's the most important? So ABCs all stand for getting air, right? Don't they? Air, breathing, circulation, which is all about air. Getting that, right? Okay. That's number one over anything else. Okay, so this is great. Now sometimes here's we've changed. We've had, obviously if you got a bull chasing you, do you need it, right? Or if you are, you're fighting something or whatever. But do we secrete that even in times of emotional stress? And in times of those types of things, we are too. Now that sounds like that's okay. That would be a really good thing because it's going to help you get through, right? Well, here's the thing, and this is just because we're animals. We release those hormones, and they are wonderful. They get us through the immediate danger. But if we're releasing them in times that we're not really in immediate physical danger, we're releasing them. Let's see if this doesn't make perfect sense to you. When epinephrine and norepinephrine are being released, everything else is being put on hold, including your immune system. You don't have to really have a strong immune system for 4 days from now when you might encounter a cold virus if you're not going to live to that long, right? So everything else is put on the back burner. Nutrition. The digestive system shuts down. How many of you are stress eaters? How many of us, I should say? I didn't used to be. I used to not, but I'm so anyway, no, okay. That's probably the absolute worst thing that we can do because our digestive systems, if we are stressed, are not getting the attention it needs to even absorb correctly what you are needing, right? Or even processing it after it is absorbed. So sometimes those things go right through you or they just won't be used the way that they're supposed to be used. Abdominal pain, all those things. All those things can happen. We should not, whatever. But controlling stress is a really important thing to learn how to do in human activities now because we have evolved so quickly past having to run and throw a spear to get our food, right, to now where we're not doing any of those things. Other things are causing us stress for longer periods of time. Do you know what has been proven to cause the most stress in developed countries to people? What's causing the most stress is not being chased by a bull, which I was once upon a time chased by a bull. No. And not my class is Dylan. Phones. Screen time. Screen time. And even our little kids, so much of it, cortisol levels go up, which are, and these levels are going up in times of that. I haven't talked about cortisol yet. But these levels are going up because of that. So it's just all about balance, isn't it? And figuring that out and taking back control of it. But absolutely, absolutely, that's important. Now, the cortex, the outer part, what I want you to know, and I'm going to hope to get to a slide that's going to help me not forget anything. What I want you to know about, can I just do it from my own memory? And y'all know that these are in your notes somewhere. Okay, do y'all mind? So this outer part of the adrenal glands, the first thing I want you to know, and I'm going to give you their names, and you'll see them called kind of in groups or whatever, but I'm going to tell you what I want you to know their names are, because I know what you're going to see in a medical situation, what they're called. From the adrenal glands, we get, and you don't need to write this down, but they're called mineral corticoids, but what the one you need to know is called aldosterone. Aldosterone. So this is number one. Well, epinephrine, norepinephrine, is in the middle of the adrenal glands, but on the cortex, the outer part, this is the first one I'm talking about. It's called aldosterone. And I'm going to tell you, just for your notes' sake, exactly what it does. It targets the kidneys. So in the bloodstream, it's going to target the kidneys. Are the kidneys very far away? Kidneys aren't very, very far away from the adrenal glands, are they? But it targets the kidneys, and let me tell you what it does. It causes the kidneys to retain sodium from the blood, keeping sodium in the blood. Now, sodium, does anybody remember? It's a cation. Do you remember what that means? It's an ion. Do you remember what kind of charge it has? It has a positive charge. Do you remember where in our bodies we have trillions of cells, but we have fluid bathing our cells, right? So we have inside our cells the fluid, and we have outside extracellular fluid. Does anybody remember where sodium predominates? Is it predominating okay, thanks. It's extracellular, not intracellular. It has a positive charge. Do you remember the ion that's got the positive charge that's the predominant one inside of our cells? Potassium. Y'all should remember that. Sodium is predominant extracellular cation, and potassium is the predominant intracellular cation. Y'all hear that? You remember that? Good, thank you. And we said that's so vital. Those ions are electrolytes, aren't they? And that balance that those electrolytes are so vital, because that's what's keeping our living cell membranes action potentials, the voltage, the electricity where it needs to be, right? And we said if anything stimulates the cell, then the exchange of those electrolytes are what cause action potentials. Are we good? So great. So we knew that. We knew that. So I'm telling y'all right now that aldosterone targets the kidneys to keep sodium in the blood. Sodium has a positive charge. So what do you think it's causing potassium to be done, to happen? Probably right behind. What is potassium doing? It's going out into the potentially to be lost in urine, right? But this is what aldosterone is supposed to do. Now, let me tell you this, and maybe you just will trust me on this. Sodium, since it is a predominant electrolyte, extracellular, sodium plays a huge role in contributing to what we call osmolarity. Now, I told y'all the definition of that. That's the percentage of solutes in solution, right? So knowing how many solutes are in that liquid is knowing the osmolarity. So what I want to tell you from that, because this is just the next makes sense thing, is where sodium goes, water follows. Where sodium goes, water follows. Because doesn't water move down its concentration gradient? We call it osmosis. Am I being too basic, Brittany? You would tell me, right? You good? Okay. All right. So guys, here's what I'm saying to you. Aldosterone from the adrenal glands targets the kidneys to pull sodium in. Water's going to follow it. So urine production goes down, but what happens to blood pressure? It goes up. So what aldosterone's really doing is raising blood pressure. It does it by making you conserve sodium. Are we good? Okay. Okay. All right. Now, there's something else from the adrenal glands I want you to know, and it's on to glucocorticoid group. But anyway, it's called cortisol. It's called cortisol. Have y'all heard of cortisol? Have you? Have y'all heard this? I'm not making any of this up. These are somewhere in your textbook. This is why you have a textbook, so you can go look these things up. But anyway, cortisol. What I want you to know about cortisol, it's amazing. We produce, adults on average about, I think it's like, you don't have to know this, but it's a little bit every day. We produce like 5 milligrams or something per deciliter. I don't know, but we produce some every day. Because we live in a hostile world. We stump our toes, we bite our lips, we fall down steps. We do things, right? So we do things and we hurt ourselves. That's all right. Cortisol is going to help. Let me tell you how it functions. It's going to have widespread functions. It's going to help with tissue repair. It's going to help with tissue repair. Tissue repair. It's going to target the beginning of new glucose. Because for tissue repair, that sounds like it's going to take some work. And what did we say helps to get us energy to do the work? Glucose. So cortisol actually is going to increase your glucose levels because it can actually cause you to actually create and make glucose. That's crazy, right? Because you need tissue repair. So if you're under stress, do you think it would be a good thing for your cortisol levels to go up? Because maybe that bull would actually catch you, right? And then you're damaged. Is that right? What happened? No, I haven't done that. That means somebody else is out there using my stuff. Okay. So it's not like it's great stuff. All right. So it sounds like when you're under stress, maybe your natural, normal cortisol levels are going to get a signal to rise. Is that right? And that sounds like that would be a good thing. Because like I said, maybe that bull caught you, right? You weren't just running from it. It actually caught you, and now you hopefully survived, and you got to heal. Is that right? Helping with tissue repair, helping. And this isn't just from trauma. This is also like colds. If you've got colds and, you feel bad, or you had the flu, or you had something, your body is under assault, in which you have cortisol levels rising, right? So cortisol is a wonderful, wonderful thing. It really helps with that. It's going to help even play a role in with those electrolyte balances and blood pressure, keeping your blood pressure where it needs to be, going up a little bit, because you're going to need all of that happening. So that's really a great thing. We can make cortisol in the lab. Do you know what we call it? We call it prednisone. Has anybody ever been on prednisone in this class? I know it's a fairly commonly used medication and drug, and what you have to be kind of careful using it though, because when you don't just use it willy-nilly, you use it when they're trying to help you get over something that's been insulting to your tissues, maybe a chronic lung, issue, or maybe it's been, maybe you've had poison ivy and you had all kinds of issues happening. So what this did was it was going to help you with that and with tissue repair. The thing about cortisol, though, is when it's going up, your immune system is being suppressed. So when you're under stress and your cortisol levels are going up for that, your immune system is being suppressed. All right? So you don't want to stay on those for too long. And you have to be kind of careful how you go off of them. Have y'all heard that when somebody gets put on prednisone, they have to wean themselves off of it gradually? And the reason that they have to do that is because they can send their adrenal glands into shock. If they go off of it gradually, their adrenal glands pick back up on the normal amounts of cortisol that will be released. The reason I'm stressing this and spending more time than I probably need to, but I hope y'all are listening, is because you all are going into health science fields. You're going to see patients who obviously are patients because they're under what? They're under some sort of stress. They're patients for a reason, right? So if they've had surgery, if they've had amputations, if they've had whatever, and their glucose levels are a little high, are you going to be thinking they're a diabetic? Not all of them, they might be a diabetic, but not always. Sometimes it's because you know the adrenal glands are doing what they're supposed to be doing. They're secreting cortisol, and their glucose levels are high because of that. I can tell you all, look it up, do your own research. Health professionals kill patients after major surgeries and after major illnesses because they will give them insulin thinking that they're diabetic, and they are not. They have high glucose levels because they have been insulted by having a limb removed, and it drops them into what's called insulin shock, and it will kill them. Insulin is a drug that is often implicated in overdoses in hospitals. So be careful to realize it's not just your pancreas that plays a role in glucose homeostasis. Your adrenal glands can contribute to glucose. And this is why they say if you are never managing stress and you are always under stress, it can throw so many things off, including your glucose homeostasis. Okay, do we all feel like we need a yoga class? I'm about to give y'all a break. Y'all okay? Everybody good?
What does the cortisol target look like?
It's widespread tissues. It's widespread. So that's one of those ones you don't really need to know a target because it's widespread. I have one more thing to tell you about, and again, I have one, and I already told you, you had it on the phones today. The adrenal glands secrete what are called sex steroids. Our androgens, which are, here it's being mostly included in testosterone, these control libido. Libido is a vital thing to have for the continuation of the species, isn't it? So libido or sex drive, if you don't know what that word is. So libido or sex drive. So men, ladies, we get testosterone from our adrenal glands, and estradiol is one of the forms of estrogen that we also get. So ladies, we go through something very different than men do, and it's actually climacteric, or what is referred to as menopause. And so when our ovaries stop producing as much estrogen as they do during the time that we are fertile, we're still getting some estrogen from the adrenal glands, right? Men are getting some estrogen from the adrenal glands. So y'all see this, and y'all knew this. We had already talked about it. Are we good with that? Let's take a break, and we're good. We're getting these. Did y'all add some hormones to your list? Did you add some organ systems to your list? Yeah, right? Right. The pineal gland, the thyroid, the thymus, the parathyroid, the adrenals, right? All right, so let's take a break and then come back because I have a little quick exercise I want you all to do, okay? For lab, but how much do y'all want? 10 minutes, 15 minutes? 15 minutes. So at 25 till, we'll come back and start a little exercise, a little lab. You good?
I can tell we get microplanes going because they crossed over today and I think we're going here. Question. I started writing.
So you're going to need to take your That's okay. It's okay. That's good. It's really, there's no separation.
Right.
The thing you're going to have to be honest about Dakota is that I don't pull something in because then it wouldn't be fair. People, you know what I'm saying? So that's going to be the main thing.
Oh, that's right. Did Dylan tell you he got married in Florida?
What did you just say? What did you say? Wait a minute.
No, don't listen. Don't pay attention.